Okay, Dave, I see you've laid out the first wall, and this looks like the wall that goes into the front of the trailer. Is that
Correct.
good? And I'm assuming that's the bottom.
Yes.
So why don't you walk us through the components here and tell us what the plans call for and how you did it?
Okay. We did the studs 2 foot on center, as you can see, because that's what the plans call for. You can usually go 16 inches on center or 2 foot on center. And if you'll notice, you'll see this double header here on the top, and you'll see this double end stud, and you'll see this double bottom plate. And the reason that is like that is because of it being on a moving trailer to give it more stability and to be able to nail it better.
So what that does is it allows you twice the area to attach your sheeting to for stability.
Exactly, correct.
And then this header beam you've got here, I see we've got basically a laminated beam, 2 2x4s, a layer of plywood together.
Correct. The reason we have 3 laminated together like this is to bring it up to a true 3.5 inches, because 2 2x4s together is only a 3 inch, so we put the 1/2 inch OSB in between to bring it up to the 3 inches so it's perfectly even.
So that's a standard laminated header beam.
Correct.
Okay. When you're framing your walls, an important thing to consider is what's called racking. A rectangle or square by itself is not very sturdy. It can torque from side to side. That's what we call racking. When that happens, all 4 corners are getting out of square. In other words, you want this to stay at 90 degrees so all your building materials fit. If it's not square, it's going to cause you problems on a lot of other phases of your build. So what Dave is going to do this morning is describe how he gets that wall square before he locks it down by putting sheeting on it. Now, if we put sheeting on this, it's going to be locked in place. It will no longer be able to rack because we've got a continuous plane across the surface. So Dave, describe what you do here.
You measure the top to see what your length is, then you measure the bottom to make sure it's the proper length, because over the wheel wells, this plate is cut. So you want to make sure that this is the proper distance. So then you nail it down, then you take your tape to square it, the guy in each end. Okay, right now this is 218 inches. And this is 219 inches. That means the wall needs to go that way 1/2 inch.
The top of the wall, correct?
The top of the wall, correct.
And then, so while you're doing that, the bottom stays in place because you've got it nailed.
Correct. So we're 218.5. Let's double check our measurement.
Securing this bottom wall seems like a critical element in this.
Very critical.
Otherwise, you'd be chasing that
And it's
wall.
218.5 right here. Now our wall's square. So we take this, take two nails, 1 on each end. You just tack it down, that way it stays in place. Now we're ready to put our strap in the middle, put sheeting on, and the wall's ready to set up.
So Dave, you're to the point where you're building your shear wall, and let's talk about some of the important bits here in front of us.
Okay, we put the strap down for the shear wall. Now I'm taking glue, putting it on all the studs.
And what's the glue for?
That's to hold the plywood on.
So you're gluing and nailing when you put your sheathing on?
Correct. That way when you're driving down the road and there's any kind of shifting or anything, and the nails want to move, the glue will still hold it in place.
Okay, and now in a shear wall, this is a structural component to the whole trailer. So the shear wall is going to resist some of that side-to-side racking that can happen also when you're going down the road and you've got those bumps. There's a couple of other important things to know when you're building your shear wall, and it has to do with where the two panels come together. So what do we got going on here?
Okay. First of all, anytime you use CDX, I usually use a nail, like an 8-penny nail. I just put it in between and put my piece right up to that, because you have to give it some room to expand and contract.
So you're creating a space there so that when these flex with the weather, they won't buckle.
Exactly.
Okay, and now I notice that this is a little bit closer spacing than you usually see. What's
Yes.
that about?
That's what the engineer spec'd out. Every 3 inches on the splices and every 6 inches on out in the field.
So that means here where you've got two pieces coming together, you're every 3 inches, but here in the middle of the panel, you can go all the way up to 6 inches.
Yes,
All
correct.
right, that sounds good. So this is going to be a really stable house.
Very stable.
So we're going to talk a little bit about how you cut the arch around the fender. And Ben, if I was a single person and I was trying to make this arch and scribe this, how would I do that? We'd set this piece up, and then what?
The easiest thing is to use a full sheet because it's sitting on the ground. And then the first thing that's important to do is to make a reference point. So if we use a square, we'll make a reference point so we have something to go off of. What we need to do is we need to lay our pencil flat on the fender.
And this is where it's really helpful to have a carpenter's pencil because you
Correct.
can lay it flat.
And notice I laid it on the side. And what that does, that gives us an additional space between the fender and the plywood when it's cut. We need to figure out the difference, since notice we didn't go all the way down to the ground. So what we're going to do is we're going to lay this sheet back and we'll measure from the ground to the bottom of the trailer. And we have 20 inches. So we'll measure up here 20 inches.
So that gives you your start point on the fender.
Correct.
All right.
We'll double check this side as well. So now we'll snap a line.
So that should give us the bottom of the fender.
Correct.
All right.
So we need to cut in on this line and then use a jigsaw and cut around the arch. And then we'll cut straight out here as well. And that'll give us the arch of our fender. Okay, notice we have the piece cut out now and we're flush with the bottom of the trailer. And we have this 1/4 inch here. It's very important to have that 1/4 inch gap. So now we'll lay the sheet up and we have our reference point here, a mark that we made earlier.
So I'm going to line this up with the mark that we made.
Correct. And we have the sheeting is hanging out over the wall, the same difference as the joist and the floor sheeting.
So the base, the sill plate is actually resting back here, and you've already
Correct.
attached the sheeting.
Correct.
And then when this wall gets stood up, then the sheeting will hang down over and it'll end up flush with this. Is that right?
It'll flush out with the bottom of the trailer, which is very important because then we can nail into the sheeting into the cedar boards we put on earlier.
You have no seam.
And
It's
that gives
seamless.
additional strength. It'll hold the trailer and the wall together.
So that's why we measured up from the bottom, from the floor.
Correct. And then that determined this point here.
Okay.
So now that we're on our reference point, I'll make sure I'm here. Now we're ready for the jigsaw.
Okay. We're about to cut out this window, and this is where eventually you'll install the window, but we have it fully sheeted all the way across.
Correct.
So the interesting thing is now, how do we get to the point where you actually have an opening in this plywood?
Okay, there's a few different ways you can do it. The best way is using a router. It has this bit right here that kind of drills its own hole. When you push down in, it drills its own hole, and then you go all the way around and it guides right around the window.
So what type of bit is that? I know there's several different types that you can get for a router. So if I was looking to purchase that bit at, say, a home improvement store, what would I want to look for this purpose?
The best thing, there's many different router bits, and the one has a wheel on the end. You don't want that one because that one doesn't drill its own hole. This one has a bit on the end. I don't really know how to explain that.
So
But
it's like a drill bit, and this piece will do the piercing,
correct, yep.
and then this part will be the part that'll actually be cutting laterally as you move it side
Right,
to side.
right. And it stays right along the 2x4 all the way around. It kind of,
Okay.
it stays right around that. You just push around.
So you've scribed a really nice opening, and it's very smooth.
Right, exactly. It's perfectly flush. And the way you do to find out where your window is when you're putting your sheeting down, just make a mark. As you can see, I have a chalk line right here. Just make a mark and then snap a line. Then you know where to push your router bit down
To plunge
into.
it down the first
Right.
time. Okay, that's great. So a router is kind of a specialized tool, and everybody might not have a router in their toolkit.
Correct.
So you mentioned there's several methods.
There
What
is.
other way would you recommend?
Another way is if you have your line snapped, you can use a skill saw to go around. That's the hardest way. I would recommend using a sawzall from the inside after the wall is up, and we can demonstrate that after we set the wall.
All right, let's get it going.
All right.
So Alan, we routed out the window opening on the outside, and we gave a demonstration of how that would work. But
Yes.
if you don't have a router, then there's several other options.
Right.
So the other option would be to use the sawzall.
Right. I told you about the skill saw when I was doing that. That's the hardest way. The other way I would recommend would be with the sawzall and take a bit. It's a 3/4 inch bit. That's a good size for a sawzall to go through. And just go right here in the corner. Make sure it has a wood blade on it. And then you just go in. Now you can see with this cut, it's nice and smooth, but here where I use a sawzall, it's all crooked and looks the way it does. But it works fine. The window will cover everything, and once everything's completed, it won't show.
So then, if you have a bump like this, where
Mm-hmm.
it's pretty severe, if you needed to grind that down, how would you do that? Would you do that with the sawzall? Or
I
you-
would, yeah. I would just go through with the sawzall again. Just make sure everything is even with the 2x4, and then just follow all the way around with the sawzall.
And that's okay if it's a little bumpy, because you've got the half-inch play on either side of your window opening.
Exactly. The rough opening in the window.
Are slightly different.
Exactly.
All right. There's another way that you can actually cut these window openings,
Yes.
and that involves using the jigsaw and also a drill and a bit. So first, what's the first step if you're using that process?
Well, the easiest way, obviously you can't use your jigsaw from in here because of your 2x4, so you have to use your jigsaw on the outside. But you need to know where your frame is on the outside, so that's what I have this bit for.
Okay.
And what I'm going to do is drill a hole on each corner, all 4 corners, and I'll do that now, and I'll show you what I do on the outside.
So then I noticed you took care to make sure that you're getting your hole pretty tight up against these two pieces. Is that
Right.
kind of so you can see where you're at from the outside?
Exactly, and then on the outside I snap lines. Now we know that line is our sill height on the inside. It's going to be exact.
And you'll repeat the process
All the
with
way around.
all sides.
For the structural strapping on your tiny house, there's some techniques to actually secure it to the structure. We want to caution you about one thing. You notice this has holes in it, and it's pretty heavy gauge steel. You can't use a regular air nailer for this because it's very unlikely you will hit the holes. You can have the nail bend or come back at you. It's not a safe way to do it. Alan, you have a nail gun that is designed for this purpose.
I do. It's a positive placement nailer. If you look at the two ends here, this one looks completely different from this one. And this, what you do is you put this right in the hole, and then it's guaranteed the nail is always going to hit that hole. Where this, if you put that, you don't know where you're at. So I don't use this kind of nailer because if you do, it could ricochet. The nail will most likely ricochet, and who knows where the nail is going to end up. Now, these nailers are, they're uncommon. You can buy them anywhere, but for someone doing it by yourself at home, it's best to just use a hand nail. Like, just go like that. That way you don't have to worry about finding a nailer like that.
Good point. And by the way, that nailer was not plugged in when you had your finger on the end, was it?
Right.
Okay, good safety tip there.
And one of the interesting things about this design is because we have the 3 windows up above, this is a large open space. And it's also kind of a weak point in the structure. So there's several really important things to make sure that you're covering and installing correctly. So here, you guys have installed the all-thread rod. This is a tension piece. So this is a piece of metal that's going to span from this side to this side, and it's gonna resist the forces that are gonna pull this wall apart. So how did you install this?
We put the wall together when it was laying on the floor, and then obviously we measured up from the bottom of the wall. We just came down a little bit below the plate, and we measured up from the bottom of the wall here, took the same measurement here and here, and then we drilled in from this end and from the other end, and because we have the large cavity here, we were able to drill through there. And then we put the nut and the washer on the one end of the all thread and drove it through, and added the nut and the washer on the other end. And
So then I did notice that this all-thread rod was a little longer than it needed to be.
yes,
So I saw Dave earlier using the Sawzall, and he was using a metal blade. Is that
Correct.
correct? When he was cutting that off.
Yes.
Now, is there anything special that you need to do to the rod after you cut it before you put that last nut and bolt on?
the important thing is to put the nut on before it's cut, because if you cut it and then try to add the nut, it's hard to get the nut started on the all thread because of the way of the cut.
So another important structural component of this front wall is the paralams. And these are a different type of lumber than what we've used on the rest of it. And again, this is to structurally reinforce this kind of weak point. So what's the difference between a paralam and a regular piece of lumber?
This is an engineered piece of material where the 2x6s that you see is just a dimensional lumber. So this is actually engineered, and it's lots of components glued together. So these are really strong, and they're also harder to nail into.
Well, I noticed that this is one of the nails that we've been using, and we're not going to make it all the way through that. So instead, we're using some larger pieces. What are these called?
Correct. These are log screws. This is a 6-inch log screw, and as you notice, if we drive that in there, it makes a better connection.
And it's gonna get a lot of depth into the top piece and be running all the way through
Correct.
the bottom part.
So the important thing is to drill a pilot hole, and in this connection here, we have 4 of the screws to drill 4 pilot holes, and then we run this log screw right in there.
And all
and
this
that'll
is
pull everything together.
and all this is accomplished when you're framing the piece on the floor before
Correct.
you lift it into place.
Correct.
The other thing that you have to do before you lift it into place is to make sure that you've drilled out for our connections to the trailer.
For the hold down strapping, correct.
All right, so this bolt here is welded actually onto the actual frame. So then when you're lifting it into place, it looks like it's going to be a little bit heavier than some of the other walls, so you want to get a couple of friends.
Correct. We needed to cut a hole into the sheeting as well, but we also need to come back now and trim up this all thread, and then our cedar trim will cover that. So we're going to cut that off so we gain that extra 1/2 inch.
And it's important not to countersink. So one way
Correct.
that you could have installed this is to drill a plug into it and then have all this be flush with the surface of this. But because it's a structural component, you want to make sure to leave this as intact as possible.
Correct.
So all this will get covered over by the time we're done, and then we'll have a very strong and stable house.
It's important to seal the bottom of this plywood, and what I'm doing is I'm just taking black paint and I'm just painting the whole entire bottom of this to seal that up so water can't get up in there and rot this bottom out.
So Dave, we're working on the wheel well inside, and we have this spot where the wall is distributing the weight side to side and not actually resting on the wheel well.
Correct.
But we still have a problem when we come to putting the interior sheathing on. So this is the method that we're using. Can you tell us a little bit about this and how you achieve this look?
Okay, what I did is I had 1.5 inches, so I just cut a 2x4 down, ran a bead of caulk along there, put the 2x4 from one end to the other, and I screwed it down because of there being the steel plate underneath. I had to screw it down, and then I just put studs right there down to the bottom plate, and you have to make sure they're tight because that's actually a bearing stud that goes up through there. And just put one under each side of the window.
So your next process will be to put the interior sheathing on after it's insulated. So that's the next thing that
Correct.
gives it a place to kind of attach to.
Yes.
All right.
Yep.
We're to the point where we need to talk about water penetration and making sure that we're protecting our house from water. And one of the worst ways that water can get into this house is at this unique joint that we have with the wheel wells. So you're saying that it's important to use silicone.
Yes. Silicone will adhere to most like metal surfaces, any hard, smooth surface, where most painter's caulk, most other kinds of caulk will not adhere to a smooth finish like silicone will.
And let's talk a little bit about how you use the caulk gun and some of the important things that you need to know as you're accomplishing this step.
Okay. First of all, yes, it does need to be clear silicone, and it'll have a tip on, and you want to cut at least a 1/4 inch hole or a 1/4 inch opening at the end.
And so then this is at a slight angle, I notice. Does it matter how you hold the gun as you're creating this bead?
Yeah, the reason you cut it on an angle is so you can hold your gun at this position. If you would cut this square, you would have to hold the gun like this.
To get a nice bead, which is harder to do.
Which is a lot harder. So you cut it on an angle, that way you can go like that.
Okay, so then what we're really accomplishing here is 3 water dams. So we're preventing, if water were to come under the siding on the outside, on the top of this wheel well,
Yes.
then it would hit 1 water dam, which is going to be a bead of silicone.
Yes.
If it gets beyond that for whatever reason, then you've got another dam, and then just for safety, you've
One
got a
more.
3rd one.
Correct.
So let's see how that lays out when we're in
Okay.
the unit. What it's important to note is that Dave has laid down a really nice fat bead, and what that's going to do is as the water is trying to come in, it's going to have a harder time resisting gravity to go up and over. So you want to make sure that, sometimes you smooth it with your finger or you do something like that. That's not this type of application.
Exactly.
You're making sure that you want it as, nice big fat, and he's going to continue those beads all the way across the top of the trailer well.
Correct.
An important thing to remember is the connection to your trailer. You'll recall that we had those tall bolts that have been welded to the outside of the trailer. On the inside, the way they're connected is with a Simpson strong tie. This one happens to be an HU5, which is a particular type of hold-down connector. And you can see that this here is the black all-thread rod that came up through the floor from the trailer. So this connection altogether creates a very strong point at which it's directly connected to the outside frame of the trailer. Art, we're not kidding when we say these are tiny houses. So one of the ways to save space as you're building out your floor plan is to use smaller size lumber for the interior non-load bearing walls.
Yeah, that's a great idea. Normally, the outside walls are framed with full 2x4s, which are 3.5 inches thick. You can save a little space by not going with that thick a wall on the interiors.
Yes. So these, for example, we framed out the toilet room with 2x2s. That's 2-inch by 2-inch dimensional lumber, which actually works out to be 1.5 inches by 1.5 inches. They kind of fool you with the wording there.
And these are not supporting a load, so the smaller size wall is going to be perfectly fine.
So you're saying I won't fall if this wall is not 2x4?
I don't think you'll bring the loft down.
Another important thing to keep in mind as you're putting up the walls and starting to frame in your rafter is that you want to make sure that the long sides of the house are flush all the way down. So this one had kind of a bow to it.
Correct.
And then how did you fix that?
It is very important for the wall to be straight, because if we don't straighten it before we do the loft, we'll obviously we'll have a bow in the faceboard. The roof panels won't come together correctly. So what we did is we added these braces. We nailed the brace on the top, and then sight the wall, and we just pull it in or out before we add the nails down there to make the wall 100% straight.
So then this brace is then what's keeping it plumb and level as you're putting on the rafters.
The diagonal brace will keep it in place and keep it straight until the rafters are in place. And also when the loft is installed, that works as a square technique as well.
So the loft adds a little bit of rigidity and it helps with tying it all together.
That's right. And the important thing is to do the bracing before the loft, because if the loft is done first, then it will no longer allow the walls to move.
And then you won't be able to pull it in or push it out as needed. Once you're finished sheathing your walls, remember that it's important to have a vapor barrier. If you're using fiberglass insulation or rigid foam insulation, those objects don't necessarily allow for the transport of moisture outside of the house. And they also don't provide a waterproof barrier from rain and things falling on the outside of your house. So this is a product called house wrap. You can find it at your home improvement stores. It's important to know when you're installing it that you want to install it with the words on the outside. It does have a right and a wrong face. When you're installing the house wrap, you want to make sure to use the correct kind of fasteners, the fasteners that are recommended by the manufacturer. The house wrap also needs to be cut flush at the bottom of the wall. This will eventually get covered by your siding. In a minute, we'll show you how to cut through the house wrap, and we'll show you how to make sure to wrap completely on the inside with the house wrap. Also, when you have a seam, you need a minimum of 6 inches of overlap every time you make a joint between one piece and the next. This piece happens to be tall enough to reach all the way up under the eaves, but you might find some that is in 3-foot strips. And if that's the case, your horizontal seams also need to be a minimum of 6 inches overlapped.
So that's it for framing. I hope we've shared enough with you so that you can now frame up your floors and walls. If you need additional information, contact us at tumbleweedhouses.com. When you lay out your wall, you're going to start with the top and the bottom plate. Now eventually, one of these is going to be on the floor at the base of the wall, and the other is going to be on the top of the wall that you've constructed. Your plans are going to dictate where the windows and door openings are going to be. When you lay out your wall, you always start from one end or the other. And the reason for that is to keep your studs at a set interval. They're either going to be at 16 or 24-inch centers. Those happen to be divisible by 4 feet and 8 feet are divisible by 16 inches and 24 inches evenly, so that the joints of your plywood will land on a stud. So our building plan calls for our studs to be on 16-inch centers. So what we'll do, with the tape hooked on this end, we'll find the 16-inch center mark, and it's designated again by a double-headed arrow and usually a bright red marking. I'm going to go 3/4 of an inch to the left of it and 3/4 of an inch to the right of it. And that's going to be where my stud is going to fall. And Meg will continue that throughout the distance of the wall.
Now, Art, we also have a window opening in this wall that we're framing up, and it calls for the rough opening to start at 43 inches. So over here, I'm going to make a mark at 43 inches, and then I'm actually going to measure to one side of that 1.5 inches. And the reason for that, the reason we did 3/4 of an inch to either side of our center mark and 1.5 inches over here, is that dimensional lumber is actually 1.5 inches wide.
Yes.
So when you're purchasing a 2x4 from the store, you might be surprised when you get it home and you take a tape measure to it and you realize it's actually not 2 inches by 4 inches. It's going to be 1.5 inches this direction. It's going to be 3.5 inches this direction.
Good point, Meg. And the reason you moved it this way is because we want the opening to start at 43, not the center of the stud.
Right, you want the opening to start at 43, and then on the other side, you're gonna measure over whatever that rough opening dimension is, and you're gonna do the same on the other side of the window opening.
So we've got our 16 inches marked, and Meg's gonna show you how you would mark the top and bottom plate so it makes assembling your wall easy.
So a very handy tool to have with you is a speed square. This is what it looks like. It's not very large. You can carry it around very easily with you, but it's a very useful tool to have. The reason that we've used both our top and bottom plate together is that eventually we want our studs to line up perfectly vertically from the bottom plate all the way up to the top plate. So we take the speed square, and where we've made a mark, I'm going to line up this lip here, and it's going to give me a perfect 90-degree angle on this side. So I'm going to line it up, I'm going to account for the width of my pencil blade, and I'm going to make a mark across both. And I'm going to do that all the way along at every mark that we made on the stud.
Now these marks are going to be the position of the studs that we separate these plates with.
Now another handy tool to have if you have multiple people working with you, another thing to know is that a conventional mark for construction is to take and make an X where the actual wood member is going to go in the future. That is helpful if you have someone else laying out the studs and screwing them together besides yourself. That way they just know this is where the stud is going to lay.
Sometimes we use that X to mark off the scrap piece of wood, but we want to make sure they don't think that's what that means.
Correct.
Now, it also might make your layout easier, and we've done this on this board. Depending on which method you're using, if you lay them out sideways or on their sides now, and you can also mark where the studs are actually going to join. On this particular demo, we're just going to keep them up top. Now, like Meg said, if you tried to mark your top and bottom plates separately, it's almost never going to line up perfectly. This way ensures that all of your studs are equally spaced on the top plate and the bottom plate. Now, when we go to assemble this wall, we're going to separate our top and bottom plate, and we would have pre-cut all of our studs ahead of time. We know how long they're going to be, and we're going to lay them out where they're going to go in this. I think that one's going to go here, Meg. Okay. And you've got the window molding there. And this is what we call a corner post. When you have two walls come together, one of them is going to be framed with a corner post on the end, and it makes attaching the adjoining wall secure. So we've already built this corner post, and it's going to go right on the end of our wall, flush with the edge. So you can see how it lays out.
Very nicely. We also have our window opening at this end, and what we've done with this demonstration is showed you the stud that's going to run all the way from the bottom plate all the way up to the top plate, and then we've already put in a sill. Now, if this were an actual window opening, it would go all the way across to a matching stud on the other side.
Our table is limited, and we're only building a small wall, a very short wall as well. We put our top plate, again, lining up all the marks that we made previously.
And then we're going to fasten this together.
And a good double check, Meg, would be to, before we start fastening, let's make sure our layout is correct. And we would start from this end, lay it out, making sure that our 16-inch centers falls on studs. Now, again, the reason this is important is your plywood material is going to be 4 foot wide or 8 foot wide, and you want that joint to continue. You want this piece of plywood to split this 2x4 or fall right in the center, so that the next piece of plywood
would come up and marry right up against it. And you would have enough surface to put both fasteners all the way down on either side of this seam.
So both ends are supported. You don't want to end up with a seam of plywood that is not supported. That would require you to put some more lumber in there to catch that seam.
Now we framed up our wall and we're ready for some other treatments to our window openings. You can notice that here we have our 16 inches on center, 32, and then we actually here at the window opening we have the one that runs all the way from the bottom plate to the top plate. But that's not going to give us where we need for our seams in our OSB and our sheathing material. So you can see that we added in another short stud. This is called a cripple stud, and it goes from the window sill down to the bottom plate, and it fills in that gap, because you can see that here we would be at 48 inches. And as we're using 4 and 8 foot length sheathing material, the seam would not have anything to attach to. So here at 48 inches, we've put in a cripple stud, and this allows our sheathing to have something supporting it. Now for your window opening, there's another thing that you'll need to do in order to make sure that your structure is fully stable and supported, and that's to put in a header above the window itself. And this header is actually going to be made out of a sandwich of materials. So you'll see that it's going to have a 2x4, and then a 1/2 inch filler strip, and then another 2x4. The reason for this 1/2 inch filler strip, as you recall from our discussion earlier, that the 2x4 material that you're using is actually 1.5 inches by 3.5 inches. And in order to make your header the full depth of your top plate, you need to actually add in that additional 1/2 inch. Now, there's several ways you can accomplish this. You might use 1/2 inch rigid insulation as a little filler strip in the middle, or you might use some of your sheathing material, either OSB or plywood, and that is going to give you the full depth that you need in order to have your header flush with the frame on both sides. When you're attaching two walls together, it's important to add a second top plate. And the reason for this is that it adds additional strength and stability to the structure where two walls might join. So you'll see here that we have our corner block, and then we have this wall, which is coming in here. Now, there's a seam there, and to overlap the corner, what we've done is we've taken the second top plate from this side, and we've extended it so that it actually comes over and actually attaches into this wall here. Now, on this side, you'll notice that the second top plate for this wall stops short. We now have an overlapped corner at the top, and that's a very strong connection. There are many different types of ways that you can fasten members together in your house, and we're going to cover just a few of them today. You're going to want to make sure to choose the type of fastener method based on your budget and perhaps also your skill level.
Absolutely. The lowest cost but the highest skill required is going to be the old-fashioned hammer and nails. Although it seems quite simple, you can really do some damage with a nail and a hammer to your finger and the material if you're not very skilled at it.
Another method is to use a drill and screws to attach the members in your house. My personal favorite, rather than a regular drill, is to use an impact driver, such as this one. For people like me, it's a little bit smaller, and I can actually reach the trigger very comfortably on this small model. The other thing is that it's lighter, and especially when you have work to do above your head, it's a little less fatigue for your arm over the course of a long day.
And you'll be using screws, obviously, with a screw gun or impact driver. The advantage of screws is you can take them out easily if you've made a mistake. They're a little more fragile. They will break a little easier than a nail, but they tend to stay in a little better.
The type of bit and the type of screw that you use should be matched, so you'll notice that this has a star drive on it, and some of these here in front that we've shown you have a star drive head. There's also different finishes with the screws that you can get at the store. For example, these might be used for general framing. This one here might be more of a decorative application, even when you need the strength of this longer size. And then these over here are galvanized or plated. And so these might be used where they might come in contact with water. On the fastening, on the siding, you'll notice that the Vischer brothers have chosen to use this type of finish screw, which has a slightly smaller head, and it's less visible after the build is finished.
So it's important to choose the right screw for the job that you're going to be doing. The other option we have on the table here is a pneumatic nail gun. Now, this is probably the most expensive of these because not only does it involve the purchase of the gun, but you'll need an air compressor to operate it. These do make a good carpenter out of somebody with very little skills. You can place a nail with these very precisely, not split the wood, and not leave those ugly hammer marks on the wood. It is a safety issue, Proper use of this equipment is paramount because it will drive a nail into anything that gets under the end, including your foot.
That's right. The other thing is that the nail gun might be a little bit faster to use. So if you're on a time crunch or something, the investment might be worthwhile if you have a little bit of a time pressure. You can buy many different styles of nails to fit inside your nail gun. These, for example, are on a 30-degree angle, and so that allows you to get into tighter spaces with those. You can also get ring shank nails or smooth nails to go into the nail gun.
Yes, the nails will be specific to the gun that you purchase. And like with all of these fastening methods, it's important to choose the right fastener for the job.